क्या आप जानते हैं कि इंसानों द्वारा बनाई गई अब तक की सबसे तेज चीज कौन सी है और वो कितनी दूर जा चुकी है? The answer is Voyager 1. Launched in the late summer of 1977, this spacecraft holds the ultimate record for human reach. It is the fastest and most distant object we have ever built. Right now, it is moving through space at about 17 kilometers every single second. That is roughly 61,000 kilometers an hour, a pace that makes the rifle bullet we just saw look completely stationary. What makes that speed especially remarkable is that Voyager has no engine running. It is purely coasting on its own momentum. This animation shows how it achieved that velocity. In 1980, the probe performed a gravitational slingshot around Saturn. It essentially stole a massive amount of momentum from the planet's orbit, flinging it permanently outward into the dark. Since that maneuver, it has carried that exact pace all the way to its current location, roughly 25 billion kilometers away.
Back in 2012, it officially crossed the heliopause, the boundary where the sun's bubble of particles gives way to the open interstellar medium. It has been traveling non-stop for nearly 50 years at speeds that defy human intuition. And yet, when measured on a cosmic scale, Voyager 1 is basically standing still. This scale shows why kilometers stop working. We must use a light year, roughly 9.5 trillion kilometers. That massive bracket represents one single light year. Look at that tiny dot on the left. After a half-century of blistering speed, Voyager hasn't covered even 1/300th of it. If it maintains its current pace of 17 kilometers a second, it will take something like 17,000 years just to cross the span of one single light year, and the void ahead is entirely empty. It isn't aimed at any particular destination, but around 40,000 years from now, its trajectory will finally take it within 1.6 light-years of a faint star known as Gliese 445. The math reduces our fastest creation to a rounding error. Against the interstellar void, human engineering effectively vanishes. But there is a smaller milestone approaching, one that makes the isolation a little easier to grasp. Sometime in November 2026, Voyager 1 will become the first human-made object exactly one light day from Earth. This diagram illustrates a light day. A radio signal traveling at the absolute speed limit takes 24 hours of continuous transit to reach the spacecraft. The reply makes the exact same journey back, a 48-hour round trip just to hear a single ping. Catching those faint returning whispers requires massive arrays of parabolic antennas scattered across the Earth, listening intently for a signal that has been degraded by billions of kilometers of open space. Think about the timeline required to achieve that. It has taken nearly 49 years of non-stop travel, faster than a speeding bullet, just to put a single day of light between the probe and our planet. If it takes half a century to traverse one light day, you simply have to multiply that effort by 365 to realize how absolutely isolated our solar system really is. Out in that freezing darkness, far beyond the warmth of the sun, Voyager survives by relying on an internal heartbeat, the heat generated by a decaying lump of plutonium. This line chart tracks a stark mechanical reality. That plutonium supply fades by about 4 watts every year. Voyager launched with 470 watts of available power. Today, it is operating on less than half of that. To stretch the remaining electricity, NASA engineers have been executing a slow, deliberate triage strategy, making difficult choices about what parts of the spacecraft to keep alive. They've had to shut down instruments one by one. The cosmic ray subsystem was powered off early in 2025. In April 2026, they pulled the plug on the low-energy charged particle instrument. Right now, only 2 science instruments are left running, one to measure magnetic fields and one to listen to plasma waves. But the available power continues to drop. In the next few years, there won't be enough power left to run anything at all. Voyager will go completely dark, and its radio will fall silent forever. But the physical machine will not stop. It will keep coasting at 17 kilometers a second, drifting through the void. Long after we lose contact, it will still be carrying its final payload. Mounted to its side is the Golden Record, a copper disc containing sounds, images, and greetings from a pale blue dot it left behind decades ago. In the endless, freezing darkness of the universe, humanity's loudest and fastest achievement, will endure only as a silent, floating memory. ब्रह्मांड के इस अनंत अंधेरे में हमारी ये सबसे महान उपलब्धि महज एक खामोश याद बनकर तैरती रहेगी,